Hello everyone and welcome. In this lesson, we're going to explore one of the most transformative technologies of our time, generative AI. Many of us interact with AI every day. We use it to write content, summarize documents, generate images, brainstorm ideas, answer questions, and even assist with coding. But have you ever wondered what is actually happening behind the scenes? How does AI generate human-like responses? How does it create completely new content? And what technological breakthroughs made all of this possible? Let's find out. What is generative AI? Generative AI refers to artificial intelligence systems that can create new content rather than simply analyze existing information. To understand the difference, let's compare it with traditional AI. Traditional AI is designed to analyze data, recognize patterns, classify information. For example, detecting spam emails, identifying fraudulent transactions, categorizing images. Its primary job is to analyze and classify. Generative AI goes a step further. It can create entirely new content such as emails, articles, images, code, summaries, conversations. For example, instead of simply identifying an email as spam or not spam, generative AI can actually write a new email for you. This ability to create content represents a major shift in AI capabilities. What are large language models? A popular type of generative AI is the large language model, often called an LLM. Examples include Claude, ChatGPT, Gemini, GitHub Copilot. They are called language models because they are trained to understand and generate human language. Large, because they contain billions of mathematical parameters that help them process and understand information. You can think of these parameters as somewhat similar to connections in the human brain that help us learn patterns and relationships. What made modern generative AI possible? Today's AI systems became possible due to the combination of three major advancements. 1. Breakthroughs in AI architecture. The first breakthrough was improvements in AI algorithms and model design. A major milestone occurred in 2017 with the introduction of the transformer architecture. This architecture dramatically improved AI's ability to understand language context, track relationships between words, process long pieces of text. This innovation became the foundation for modern language models. 2. Massive amounts of training data. The second breakthrough was access to enormous amounts of digital information. AI models learn from websites, books, articles, research papers, code repositories, publicly available text sources. This vast collection of knowledge helps AI learn language patterns, concepts, and human communication styles. The more diverse the data, the broader the model's understanding becomes. 3. Increased computing power. The third breakthrough was computational power. Training modern AI requires enormous processing capabilities. Specialized hardware such as GPUs, graphics processing units, TPUs, tensor processing units, allows AI systems to process massive volumes of data efficiently. Without this computing power, today's generative AI systems would not be practical. Understanding scaling laws. Researchers discovered something interesting as AI models grew larger. When they increased model size, training data, computing resources, performance improved consistently. Even more surprising, entirely new capabilities began to emerge. Models started demonstrating abilities such as problem solving, reasoning, summarization, adaptation to new tasks. These capabilities were not explicitly programmed into the system. They emerged naturally as models scaled. This phenomenon is often referred to as emergent capabilities. How do large language models learn? Let's simplify the training process. During training, a language model reads enormous amounts of text. Its objective is simple: predict what comes next. For example, if the model sees the capital of France is, it learns that the most likely next word is Paris. It repeats this prediction process billions of times across huge amounts of text. Over time, the model learns grammar, language patterns, relationships between concepts, contextual meaning. This phase is known as pre-training. Fine-tuning the model. After pre-training, the AI undergoes an additional stage called fine-tuning. During fine-tuning, the model learns how to follow instructions, provide useful responses, improve accuracy, avoid harmful content, interact more naturally with users. Human feedback often plays an important role during this stage. This helps shape the model's behavior to become more helpful, more honest, safer to use. What happens when you use AI? When you interact with an AI assistant, you provide a prompt. The AI reads that prompt and generates a response based on patterns learned during training. An important thing to understand is, AI is not searching for a pre-written answer stored somewhere in a database. Instead, it generates a new response each time based on probabilities and language patterns. This is why responses can vary even when similar questions are asked. Understanding the context window. AI has a practical memory limit called the context window. Think of it as the AI's working memory. The context window includes your current prompt, previous messages, information shared during the conversation. The model uses this information to maintain context. However, it cannot automatically access information that falls outside this context window unless additional tools are used. This means AI does not have unlimited memory during a conversation. Why modern generative AI is powerful? 3 major characteristics make generative AI so powerful. 1. Learning from massive amounts of information. AI can recognize complex patterns across enormous datasets. 2. In-context learning. AI can adapt to new tasks simply through instructions provided in your prompt. For example, you can ask the same AI system to write an email, explain a concept, generate code, summarize a document, without retraining the model. 3. Emergent capabilities. As models grow larger, new abilities often appear naturally. These capabilities frequently surprise even the researchers who built them. Examples include advanced reasoning, multi-step problem solving, creative content generation, complex analysis. Summary. Let's quickly recap. Generative AI is different from traditional AI because it creates new content rather than simply analyzing existing data. Large language models are a form of generative AI trained to understand and generate human language. Modern generative AI became possible because of 3 major advancements: transformer architecture, massive training data, powerful computing resources. These systems learn by predicting patterns in language, undergo fine-tuning to become more helpful and safe, and generate responses based on learned relationships rather than stored answers. The 3 key strengths of generative AI are learning from vast amounts of information, adapting to new tasks through prompts, developing powerful emergent capabilities as models scale. Understanding these foundations helps us better appreciate both the power and the limitations of today's AI systems. Thank you, and in the next lesson we'll explore what generative AI can do well, where it struggles, and how to use it effectively in real-world scenarios.